Welcome to the Cambrian of Morocco. I'm glad you made it to a topic which is certainly not in the focus of the modern world. This is the first part of two presentations which will provide some insights into the Cambrian rocks, stratigraphy and paleontology of Morocco. I will try to keep the topics as easily understandable as possible without reducing the information in a way that makes it worthless for people interested in more sophisticated problems. This part 1 will present a few introductory data for those of you who are not very familiar with the region and the Cambrian on a global scale. It will then present a sort of narrative of early history of research on the Cambrian in Morocco, and finally there will be data on the stratigraphy, depositional history of the Meseta Region and the Tamlelt Inlier of the Eastern High Atlas. A much more comprehensive second presentation on the Cambrian of Morocco will deal with the Cambrian of the Anti-Atlas and High Atlas ranges, which belong to the most important regions of Cambrian rocks and fossils worldwide. This is a modern map on the globe. All red dots here mark prominent occurrences of Cambrian rocks, which have some relevance for the reconstruction of early history. There are many more localities, but this map illustrates, even in this version, that Cambrian rocks are more widely distributed as commonly assumed, even by most professional geoscientists. Nevertheless, Cambrian rocks are unknown from vast areas such as most parts of Africa and South America, where older cratonic rocks form the surface, and Cambrian rocks have not been deposited there or have been eroded since. Morocco lies close to the center of this map, and in some aspects is also a central role for the Cambrian on a global scale. Let's zoom in and have a look to a satellite photo of the snow-covered High Atlas and the Anti-Atlas south of it. Indeed, the Anti-Atlas is among the region of this planet with the largest outcrop of Cambrian rocks, and one could virtually walk only on Cambrian rocks from the Atlantic coast in the southwest to where the Jebel Ugnat region of the eastern Anti-Atlas is finally covered by young desert sediments in the northeast over a distance of more than 500 kilometers. Another satellite photo shows part of the central Anti-Atlas, and it nicely illustrates how single stratigraphic units down to formations and members can be recognized even from space. I have marked just two of the major Cambrian units, the Jebel Wabermast Formation and the Adudu Formation, that will be explained in some detail in part 2 of this series. Morocco has become famous for excellently preserved fossils on the global fossil market. Particularly well known are the superbly preserved trilobites from the Devonian of the Anti-Atlas, which are the basis for an entire economic segment in the eastern Anti-Atlas. 3 examples of such Devonian trilobites are shown here. Cambrian trilobites are also popular among fossil collectors. The boom started with large Paradoxitis type specimens from the eastern Anti-Atlas in the early 1990s. So these specimens were from approximately the same region as the Devonian ones, but others from older Cambrian rocks in the western Anti-Atlas became more and more distributed during the last 2 decades. To the left you see one of the specimens with which all began, complete dorsal exoskeleton of Acadoparadoxitis briareus from the small village of Tarhusht in the Jebel Ugnat region, and to the right an impressive series of specimens of this species from a fossil shop at a rest area on the Moroccan motorway north of Marrakesh. This later photo was taken during the Bonanza period more than 15 years ago. Specimens of Acadoparadoxitis briareus are less and less quarried, so that you find more and more smaller specimens of 2 similar species on the market. But also offered are numerous faked specimens, such as this one. Such faked specimens are often easily recognized by anatomical absurdities. Some examples for this. On the left you see a partly faked specimen of Conomigmaca with a pygidium and most of the thorax correct, but probably coming from two different specimens and with a partial cephalon, with all the intermediate areas made up by synthetic film compound. On the right side you see one partially faked Acetoparadoxides with a repaired portion encircled. Below is a specimen of the Holmate trilobite Cambropallas with the entire anterior half modeled by filling compound, and in the lower right corner a completely synthetic mold which was inserted into a slab of normal sandstone. These trilobites, particularly the paradoxidids, bring us already to a problem of Cambrian stratigraphy in general and of the Moroccan and West Gondwanan Cambrian stratigraphy in particular. Traditionally, the Cambrian succession of Morocco have been subdivided into a Georgia and an Acadia. These names originate from the Eastern North American traditional terms for the Lower and Middle Cambrian, and there, as well as in Morocco, Middle Cambrian rocks are easily recognizable by the presence of a characteristic trilobite genus, Paradoxides. In other words, where you find Paradoxides in broad sense, you are in the Middle Cambrian. Older rocks with Cambrian type fossils were called Lower Cambrian. Ironically, the earliest complex subdivision of the Lower Cambrian into formal zones defined by trilobites was indeed introduced in Morocco. Pierre Huppé, whom we will meet later again, introduced such a trilobite-based zonation for the Anti-Atlas with in total 8 biozones distinguished in 1952, 1953 and is shown in this table. The zonation has been revised for the Anti-Atlas and High Atlas for some levels and extended upwards and also a bit downwards as shown to the right. Now it becomes a bit more hardcore. The zones can be translated into chronostratigraphic units to subdivide Cambrian time rather than rocks, and this resulted into regional or continental schemes with series and stages. The relevant column for West Gondwana is shown in the green column and unites what we know not only for the Moroccan Atlas regions but also for the Cambrian of Iberia, that is Spain and Portugal, southern France, Sardinia, Central Europe, meaning Germany and Bohemia, Turkey, Israel and Jordan. Nevertheless, the International Subcommission on Cambrian Stratigraphy started a subdivision of the Cambrian on a global scale some 30 years ago and came up with a subdivision into global series and stages, the present version of which is shown to the left. I cannot go here into much depth explaining the whys and hows of the differences, but I would like to discuss the impact on the traditional Lower Middle Cambrian boundary. Huppé's original zones, here now marked in blue, represent the Georgian of the Moroccan stratigraphy. The occurrence of paradoxides in broad sense is now shown by the green area, and this is the traditional Middle Cambrian. It is easily recognizable that it overlaps with the Georgian. So the traditional Lower Middle Cambrian boundary would be at this stippled line. However, the base of the newly introduced Meolingian series, which replaces the Middle Cambrian globally, sits distinctly above it. In other words, a considerable part of the traditional Middle Cambrian strata of the published articles in countries like Morocco, Spain and elsewhere now falls into the provisional yet unnamed Series 2 and Stage 4, which has the smell of early Cambrian. This is the international scheme for the entire Cambrian as shown on the recent stratigraphic chart of the International Commission on Stratigraphy, which suggested radiometric ages for all the stage boundaries. I show you here the approximate early lower, middle and late upper Cambrian series, and the red circles shown here indicate that they do not correspond to the traditional boundaries. So keep this in mind when referring to earlier scientific studies. Another topic to mention is that ICS still maintains a wrong date for the base of the Cambrian as it is presently defined. This should indeed be 539.6 rather than 541.0 million years. For those of you who are not too familiar with the Cambrian, I would like to emphasize that the Cambrian series 2, the Merovingian and the Varangian, or the stages 3 through 10, are those ones in which trilobites occur and also constitute the major faunal elements. Originally, scientists believed to recognize three intervals, lower, middle and upper Cambrians, by distinct trilobite types identified as the redlichioids, the paradoxidioids and the olonilids. However, a pronounced faunal provincialism can be identified for most of the Cambrian, and these morphotypes are now more or less a topic of science history. Trilobites are absent from older strata of the Ternovian series, which remains of skeletalized animals, and these skeletal elements are usually found isolated and were often not identified in terms of systematic position of these animals. They were thus lumped into an arbitrary group called small shelly fossils, abbreviated here as SSFs. Such fossils start in its existence close to the base of the Cambrian and range up throughout the entire Cambrian. One last word to the Georgian and Akkadian. From a present-day viewpoint, it appears a bit odd that French and Moroccan stratigraphy stick to the Georgian and Akkadian for such a long time. These terms reflect the historic concept that Scandinavia, Western and Central Europe, including most of the British Isles and parts of North America, reflect paleogeographic unit termed the Atlantic Province. Nevertheless, the famous George Doolittle Walker already in 1912 illustrated the deficiencies in such traditional thinking when he wrote, quote, "With the development of the mapping of the geological formations of the United States, it has increasingly become evident that the use of more than one term derived from the same geographic name is faulty in principle and confusing in usage. I have long been guilty of doing it in the use of Georgian for the Lower Cambrian series and of formations." End quote. Indeed, the Earth looked quite different from today during the Cambrian. A large number of paleogeographic reconstruction has been published, but lamentably most of them can be shown to have enormous deficiencies. The reason for this is that magnetostratigraphic data flow into its preparation primarily, but biostratigraphic data, which would be needed for refining the time slices, are mostly poorly used. Here I show a reconstruction for stage 4, which to my understanding is fairly sound. It should be noted that it lacks the usual distinct lumping of continents in a polar or subpolar position as in others, which cannot be correct based on the distribution of fossils. Shown on the map are land masses in brown, marginal marine to shelf settings in green, and oceanic regions in blue, as well as three trilobite groups, which are characteristic in a biogeographic sense. Olonilines are typical for the Laurentian part of the present-day North America. Paradoxidines are characteristic for Baltica, Scandinavia, including the East European platform, Avalonian, Eastern North America, and also the British Isles, West Gondwana, including Morocco, which you see in this yellow area and particularly in the red circle, and the Siberian platform. And finally, redlichioids finally are characterized for East Gondwana, including Australia, North China, South China. Nevertheless, Olynelines and Rettlichines are early Cambrian trilobites, whereas Paradoxidids are Middle Cambrian, so that these provinces are diachronous. In fact, the oldest trilobites characteristic for the faunal realm to which Morocco belongs are characterized by the mostly neglected group of the Bigotinids. The present-day Moroccan Cambrian, as well as the other West Gondwanan regions, are situated in a much more equatorial position than shown in most other reconstructions, where the Moroccan sector is placed in a subpolar position during the Cambrian Ordovician. This is hardly conceivable when looking to the Cambrian depositional characters and to its faunal composition. Another myth of Cambrian paleogeography is that Avalonia broke loose from West Gondwana during the Cambrian. Avalonia was well off West Gondwana already at the beginning of the Cambrian. The considerable Cambrian volcanic rocks that are visible in early and middle Cambrian strata of Morocco and other West Gondwanan regions just indicate lateral extension and have nothing to do with a pronounced continental breakup. I will comment on this later. It is certainly helpful to have fancy apparatus and lots of research money, but in fact brain power is always needed to put all data into a correct framework. Let me add a last remark before we eventually get into the details of the Moroccan Cambrian. Subdividing rocks is not an easy task, but precise tools and prescriptions are provided. The subdivision and naming of rock units and time is regulated by the International Commission on Stratigraphy and by an international stratigraphic code. Why the rules are often not correctly applied is a mystery to me. Several aspects which are not covered by the International Stratigraphic Code are detailed in the North American Stratigraphic Code, which is a logical complement. Lamentably, almost none of the Moroccan map sheets and their explanatory notes confirm perfectly with the rules given in the International Stratigraphic Code and in the North American Stratigraphic Code. Well, a view to the geological map of Morocco indicates that Cambrian rocks are found in a number of different regions, particularly those highlighted here. And it becomes obvious that this is a sort of a jigsaw puzzle. To date, it is resolved to a sufficient degree, but not entirely. This is a structural map of northwestern Africa, showing the different regions identified according to their geotectonic history. Cambrian rocks in Morocco are known from the western Meseta region, the Anti-Atlas and the southern High Atlas region, and the Tamlelt region in the eastern High Atlas mountains. Rewinding the tape of Earth history, the different structural regions are shown here in the left map with their position during the Devonian, and on the right pushed together to their present-day position. So we do not have a clear picture of the detailed paleogeography during the Cambrian in what is now Morocco, but we know that the Meseta region depositional area was not in a position comparable to that of the present-day geography. It should also be emphasized that Paleozoic rocks have a much larger distribution, and this is tentatively shown on this map. Therefore, certainly much more Cambrian rocks are to be discovered. Let's again have a look to the distribution of Cambrian rocks. The largest outcrops and by far the most complete successions are in the Anti-Atlas and in parts of the Western High Atlas, and this will be discussed in detail in part 2 of the series. Here today I will provide a glance to the Cambrian rocks in the coastal Meseta in the Casablanca region, the Rihamna and the Tamlelt regions as part of the Western Meseta domain. I will do this by means of a narrative of the early research history and add a few remarks to the early research history in the Anti-Atlas and High Atlas up to about 1950. And finally, there will be a short characterization of the Cambrian in the Eastern High Atlas, the Tamlelt Inlier, which is poorly known and remained largely unstudied until about a decade ago. An overview of the succession of Cambrian rocks indicates significant differences between the different regions shown here, but also reveals some general traits which in turn reflect regional coherences as well as global signatures in sea level developments. Very generally and very crudely simplified, formations with similar lithologies of their rocks are shown here in the same colors and with their dimensions according to the supposed stratigraphic range. Recognizable is a lower transgressive branch with a significant amount of calcareous shelf deposit, followed by a shale-dominated high stand deposits and distinctly regressive development dominated by coarse silicic clastics. And this is followed by typically Middle Cambrian, rather monotonous fine siliciclastics. A closer look reveals that this Middle Cambrian grand cycle is indeed composed of a transgressive and a regressive half cycle, followed by another transgressive development reaching into the Upper Cambrian. Now let's review a bit of the early research history of the Cambrian in Morocco. This is an envelope of a letter sent by mail from Casablanca in May 1916, almost during the same days in which the Cambrian of Morocco was discovered, or at least recognized for the first time. This is particularly remarkable because it was also the first recognition of Cambrian rocks in Africa. The discovery is said to have taken place in the area of the Casablanca airfield shown on this postcard. The fellow who made this first discovery of Cambrian rocks based on trilobite fragments was Louis Gentil in 1916. Gentil was an Algerian-born geographer, geologist and mineralogist who became a lecturer at the Sorbonne University in Paris. From 1902 on, he was interested in the geology of Morocco and undertook a number of travels for field studies, culminating in a report in 1906, accompanied by a map at 1 to 250,000 and a geological sketch of Morocco in 1912. In 1913, he proposed to establish a scientific Institut Scientifique Cherifien, the responsibility of which should include to create a geological map of Morocco and to specify the water resources. This institute was indeed founded a few years later in 1920. Gentil continued the explorations of the Moroccan Atlas regions until his death. Unfortunately, Gentil did not recognize the trilobites from Casablanca as Cambrian in age, so that this important discovery remained unknown for quite some time until the trilobites were identified correctly as Middle Cambrian in age. In Gentil's map, the Cambrian outcrop at Casablanca are shown as Cretaceous in age. Subsequent comparison with Silurian fossiliferous strata from regions with similar facies prompted to consider the Cambrian rock as Silurian. As mentioned, Gentil unearthed Middle Cambrian trilobites on the airfield at Casablanca in 1916. It should be noted that this airstrip can be matched with the airport portrayed in the famous movie Casablanca of 1942, but should not be confused with the present-day airport Casablanca, which is located way east of the town. Ironically, another airfield was named after Chantilly. This Louis Chantilly field is now abandoned and was located approximately 6 kilometers north-northeast of Yusufia, about 170 kilometers southwest of Casablanca. As a matter of Chantilly's lack of paleontological expertise, Cambrian trilobites were in fact discovered first by Georges Lecomte. His notes from 1918 were the first records on the presence of Cambrian and also Ordovician in northwestern Africa, which is also the first recognition of trilobite-bearing Cambrian in entire Africa. Georges Lecomte was introduced to paleontology in his early youth by his mother, Countess Henriette Valentine Hubert Pierre Lecomte, who in her Château de Grémont had a considerable fossil collection. Georges Lecomte obtained a degree in chemical engineering in Nancy in 1906 and then switched to geology. In 1913, Émile Ock proposed to him to study the Neogene and Quaternary of the Atlantic coast of Morocco. A grant allowed him to travel to Morocco in 1914, where he began to work on a thesis in the north of Oued Sebou. However, he then was mobilized on the spot for the French army, gravely ill and hospitalized at the hospital of Anfa near Casablanca. He took advantage of his convalescence to discover Cambrian faunas with paradoxides in slates and quartzites on the coast near Casablanca. In 1918, Lecomte reported that he had studied a section near Ilot de Sidi Abderrahman, a tiny village in the outskirts of Casablanca in Morocco, in July 1917. Another, now much more frequently cited locality with Cambrian trilobites discovered by Lecomte is referred to as Sidi Abdallah Belhaj, which is located at the seashore north of Ain Seba quarter in the northeastern part of Casablanca. Lecomte studied a few Cambrian occurrences in the vicinity of Casablanca and provided the first sections as shown on the left. He had discovered numerous trilobite remains, including some thoracic fragments which he regarded as poorly preserved remains of the genera Ptychoperia or Hixia, Animacare, and Paradoxides. Lecomte correctly stated that the presence of Paradoxides indicates a Middle Cambrian age or Akkadien. And this discovery temporarily reoriented the research of Lecomte, which focused on the Paleozoic areas of the Western Meseta, and culminated in 1926 with the first regional monograph published on Morocco. Later, he devoted his work mainly to the study of Pliocene and Quaternary strata in western Morocco. The trilobites from Sidi Abdallah Belhaj and subsequent findings near Mohammedia were later referred to as Paradoxides mediterraneus, Conocoryphae, Heberti, and so on. These determinations originate in part from a short paleontological study of the trilobites by Henri Monsuy in 1922, which I will mention again in a minute. The Sidi Abdallah Belhaj locality became quite renowned as a fossil site, particularly by recollection of trilobites by Ballois in 1949, and some of Ballois' specimens are shown here on this slide. Other Cambrian trilobites from the region were figured as line drawings in the first monograph on Moroccan fossils by Henri and Geneviève Termier. This here is a compilation of their Cambrian trilobite figures of specimens which were mostly collected from Sidi Abdallah Belhaj. Trilobites can still be collected at Sidi Abdallah Belhaj near Mohammedia at the Oued Nefifik. This slide shows two examples of specimens from Sidi Abdallah from a private collection in France. And these are superb trilobites from Oued Nefifik from the same collection. Let's have a glance to a Google map satellite photo of the coastal Meseta around Casablanca. This first yellow dot indicates the position of the old Casablanca airfield. Sidi Abdallah Belhaj lies here directly at the coast between downtown Casablanca and Mohammedia, where a Cambrian outcrop is known from the small cape north of the city near the port, and the Newet Nefifik locality approximately where the motorway traverses the valley. All these outcrops belong to a lithostratigraphic unit which was originally termed the Schista Paradoxis, in English the Paradoxitis slates, and all provided a trilobite fauna which dates into the middle part of the Meolingian or Middle Cambrian if you prefer this, so they indicate a Drumian age. A younger lithostratigraphic unit crops out around a cape termed El Hank in the outskirts of Casablanca, which I will show in a few seconds. Southwest of Casablanca lies another famous Cambrian locality known as Sidi Said Marjou, which is best known from a monograph by Marcel Gigou. This locality has also produced a number of fairly well-preserved trilobites, including some which seem to be older than these trilobites from the Casablanca area and include Woolyuan trilobites. This is a view of the El Hank lighthouse, which is built on resistant quartzite-type rocks. These rocks are already recognized in Lecointre's publication of 1926 and are now identified as the El Hank Formation. No distinctive fossils are known from this unit, but it is clear that this formation is younger than the Paradoxitis slates. Obviously, the El Hank Formation represents the youngest part of the Meolingian. This on the left is a view of the locality on a postcard of the 1930s. After fossiliferous Cambrian strata had been discovered in the greater Casablanca region, French geologists discovered Middle Cambrian fossils in the Rehamna and in the Jebelite regions of the western Meseta. The distribution of the Paleozoic rocks appears to be fairly random, but in fact it isn't. A structural map clearly indicates that the occurrences are confined to a roughly north-south directed major graben system in the western Meseta, and its southern prolongation extends well into the northern part of the High Atlas range. This graben system largely agrees with areas that underwent differential block faulting during the late Neoproterozoic and the Cambrian, and I will be explaining this in some more detail in the second part of this lecture series. For now, it should be emphasized that the presence of an obvious absence of lower Cambrian rocks in different areas of the western Meseta may be attributable to such differential block faulting. The most successful geologist in terms of discovering Cambrian strata in this phase was probably Jean Barthou, who found Cambrian trilobites in the slaty argillaceous shales of the Rehamna and the Jebelite in 1922 and 1923 and published notes in 1924 and 1926. Jean Barthou had some help from Jean Monsuy, which is an almost legendary figure in trilobite paleontology in France. Monsuy was born in Paris in 1857 as a son of a plasterer from Saint-Mihiel in the department of Meuse, who became a peacekeeper in the capital. After a difficult youth, Monsuy became a tailor. After 5 years of military service, he cultivated himself, took evening classes and excursions in natural history. However, having a rebellious temperament, he went from job to job, partly as a candle maker and even a digger. Finally, Professor Vernon, anthropologist of the Natural History Museum in Paris, gave him a job in 1901 as a preparator for the French Geological Survey of Indochina. Monsuy was already 44 years old then. A young engineer, Henri Lantenois, brought him to Yunnan in 1903 and 1904 and was impressed by the knowledge in paleontology of Montsouis. In 1904, Montsouis became officially a geologist of the survey. During 3 extended expeditions, Montsouis became extremely knowledgeable with Paleozoic fossils. He was guided by Henri Duvillier, a famous professor of the École des Mines. However, Montsouis was also somehow part of the famous Deprat affair, which has been topic of several books meanwhile, and which everybody interested in science history should know. Whatsoever, the young geologist and paleontologist Jacques Deprat arrived in French Indochina in 1909 and became a friend of Montsouis. Montsouis published several monographs of undisputed quality, mainly describing the findings of Deprat, which in part were apparently not found in Indochina but smuggled into the studies. As he approached the age of 60, Montsouis became more and more withdrawn. The tributes paid to his science seemed to have developed him the feeling that Deprat exploited it. Finally, Montsouis' mood seems to have boiled up and created all the trouble between Montsouis, Deprat, and Lantenois. But this is another story. Try to catch one of the books. For the Moroccan findings of Part 2, Montsouis published a first short note in 1922 in which he claimed to have determined the well-known Bohemian trilobites Paradoxitis rugulosus and Conocephalitis sulceri. Montsouis was obviously influenced by the low number of Middle Cambrian trilobites known at that time, which were dominated by Bohemian species. However, he recognized a new species, Tychoperia partusi, although he got the systematic relationships of the species quite wrong. The species is remarkable for itself and has a distinct stratigraphic significance. Some of the specimens collected by Jean Partout in 1923 at Wet Gemat are shown here, easily recognizable by the strange crests on the head. In fact, this species belongs to the genus Berthollesia and is an index fossil for the Middle Cambrian, in other words, for part of the Drumian stage. In fact, the Meseta region yields fairly well exposed and relatively continuous sections which still await more systematic studies, particularly in the infoot syncline near the Umrebia Dam. This infoot syncline area has perhaps the best studied Cambrian in the western Meseta, so that there is a relatively well-known succession starting with the Schista paradoxidis, overlain by the Elhank formation and with an Upper Cambrian Darbu Assa formation on top. Unfortunately, trilobites remain scarce in the area, but numerous trace fossils have been studied. This photo gives an impression of the situation with plenty of trace fossil specimens visible on a single bedding plane. And here are examples of the vertical tubes of Scolithus and Monocraterion, as well as simple U-shaped burrows and dimorphichnous type U-shaped sprited burrows in the Elhank formation of the infoot syncline. The micaceous shales of the Darbu Assa formation above the Elhank formation yield numerous billing-cellid brachiopods. Billing-cellids were particularly frequent in the early part of the late Cambrian, and this formation is then overlain by Ordovician rocks. On the international stage, the Paleozoic of Morocco was reported for the first time by Philibert Rousseau. On the International Geological Congress of Liège in 1925, Rousseau presented a list of fossils discovered in the Casablanca Bay and suggested a mid-Cambrian age for the strata and rejected previous age assignments. The map shown here is the first one to emphasize Moroccan pre-Carboniferous Paleozoic rocks in general. Rousseau had studied medicine and natural sciences and received his PhD at the University of Lyon in biology in 1912. Starting his professional career in Tunisia, He became a military physician in Morocco from 1913 to 1938 and leader of the hydrogeology department of the Institut Cherifien in 1927. It should be mentioned that Rousseau was one of the early scientists promoting the continental drift mentioned in his publication of 1930 and 1933. At about the same time, Louis Chandil conducted exploration field trips. In 1924, he reported the presence of a thick lower Cambrian carbonate succession in the anti-atlas, and some of his results are already included in this map. Unfortunately, he only sampled brachiopods and fragmentary trilobites, which were inadequate to date these strata precisely. Philibert Rousseau has also been the senior delegate of Morocco on the International Geological Congress in Brussels in 1922. He also discovered Cambrian rocks in the Tamlelt region in the Jebel Hout area marked here in the red circle in 1927, when almost synchronously 4 important discoveries of Cambrian rocks happened. Rousseau's work on Jebel Hout were a byproduct, but his discoveries included archaeocyath in the area, which is the oldest report on early Cambrian rocks in the Meseta Basin. However, Rousseau was also able to synthesize a stratigraphic section with Pardou's earlier discovered paradoxitis slates on top, now with the trilobites identified as Paradoxitis spinosus, Agrolus sedicephalus, and Conocoryphae hiberti. This unit is underlain by slates and quartzites with Paradoxitis. The basal unit includes archaeocyath-bearing limestones. Edouard Roche discovered Cambrian rocks in the western Tamlelt region in 1927. The archaeocyath were recollected in the 1970s by Françoise Debrenn with the help of her husband, the non-paleontologist Max Debrenn. Françoise Debrenn published a tremendously detailed paper on them in 1977, and I'm showing here a photograph of 2 of the endemic species in thin section. This here is Rectanulus aporosus, and this is this larger section with several specimens, mostly of Ichthyosaurus perforatus, also an endemic species. Provides a nice impression of the relative high diversity in this archaeocyath reef at Jebel Hout. Just as a short sidestep, the Jebel Hout area recently gained a pronounced interest because of the findings of ancient remains of Homo and its significance on the younger part of human evolution. I should refer to the publications of Hublin in 1992 and Richter et al. in 2017. The area of this hominid fossil site is shown here. Despite of the archaeocyath limestone at Jebel Hout, the first recognition of Lower Cambrian in Africa dates back to the discovery of reworked limestone boulders with archaeocyath and trilobites cross-sections by Jacques Bourcard, also in 1927. These limestones at the beach of Sidi Moussa Daglu, west of Tisnit, at the western tip of the anti-atlas shown here in this map. Jacques Bourcard was a French geologist and oceanographer who prepared his PhD thesis at the Sorbonne University in Paris in 1922 on the geology of Albania. He became director of the Institut Cherifien in Morocco in 1925 and returned to the Sorbonne in 1933. His discovery at Sidi Moussa Daglu was certainly accidental, but the rocks there are often eye-catching, and as illustrated by Bourcard's fine figure to the right. The archaeocyath reef stretches to the beach with typical dumpling-shaped boulders, but there is not much possibility of measuring a section. The rocks also include plenty of trilobite sclerites, which remained unstudied to date. the reports by Burkhardt in 1927 and subsequent ones by Burkhardt and Levillain in 1928, 1929 and 1931 also account for the first well-recognized record of Cambrian fossils from the Anti-Atlas and thus from the early Paleozoic Suez Basin. The archaeocyaths were described in detail by François Debren in 1964. I am just showing a few examples from thin section, starting here with Robustocyathus densus. Here you can see two examples of endemic archaeocyath species from Sidi Moussa from Burkhardt's original collection. What is also recognizable is that the preservation differs quite distinctly. Specimens often recrystallized or affected by tectonic stress of subsequent Hercynian orogeny, as recognizable in the slab to the left. The early 1930s featured a high number of new discoveries of Cambrian rocks in Morocco, but now mainly in the High Atlas and in the Anti-Atlas ranges. This includes discoveries of Edouard Roche, who eventually published the first comprehensive synthesis of stratigraphical data in 1950. To name just a few others, Léon Maury was among the first geologists to study the block with non-metamorphic lower Paleozoic rocks in the Western High Atlas, and also one of the first sparkling figures turned up, Louis Neltner. He discovered Cambrian rocks in the High Atlas ranges in 1928 together with Maury, and he extended his work, which eventually led to the recognition of trilobite and archaeocyath bearing lower Cambrian rocks in the Western Anti-Atlas, including a first report of the faunas from the now renowned Tiout section published in 1929. Louis Neltner was a mining engineer and geologist who became deputy chief of the Department of Mines and Geological Map of Morocco from 1927 to 1931, together with Pierre Terbuchol. In 1931, Neltner became professor of geology at the École des Mines in Saint-Étienne in France, but he continued episodical work in Morocco until the 1950s. Neltner was certainly responsible that several of the classical localities in the Western Anti-Atlas became renowned, such as Amuslek, Tassimurd and the Isafin syncline. Among Neltner's major contributions were studies in stratigraphy and on trilobites from the High Atlas and the Anti-Atlas. They predate the major monograph of the Cambrian biostratigraphy and taxonomy of trilobites by Pierre Huppé. One of the most famous fossil localities lies at Tizi-Ouzdat near Urica-Mast, now Urica-Wabermast, close to Ouarzazate. This locality was discovered by Jacques Bondon. He published a note on this together with Louis Neltner. Jacques Bondon is the fellow with the glasses and without a cap in this photo. He began his geological career in Morocco and worked at the Geological Survey with Louis Clarion and Louis Neltner. He published geological studies in the Sahara sector with publications on the Tindouf region in 1932 and the Dra plateaus in 1933. The Urica-Wabermast fossil horizon, discovered by Jacques Bondon, was primarily a bioclastic limestone, which was termed by Bondon and Neltner the Breche à Micmaca. This is now considered a key level for the lower Middle Cambrian boundary interval. This level allowed correlations with strata in the UK and North America, and it contributed to distinguishing the Georgian from the Akkadian, so the Lower Cambrian from the Middle Cambrian. One of the key species is the trilobite King Aspidoides brevifrons, the holotype of which is shown here and was collected. The specimen was collected by Jacques Bondon. As a matter of historical practical constraints, the activities of the geologists organized by the Service Géologique du Maroc dramatically decreased during World War II. Neltner continued fieldwork. He prospected the Isafin Valley and visited the now classical localities of the Sousse Valley together with Georges Joubert during the winter of 1942 and 1943, which actually marked the start of an extremely prolific publication history of Joubert. Joubert later dominated the stratigraphical research on the late Proterozoic and earliest Paleozoic in southern Morocco. Georges Joubert was born in 1908 in St. Petersburg in the Russian Empire and became geologist and hydrogeologist, a specialist in mineral exploration and geological mapping. He is known as one of the greatest connoisseurs of Moroccan geology and a pioneer, sometimes called father of the Moroccan geology. Georges Joubert started his career with a study on Mount Tabor in the French Alps and the Vosges Massif, working in the Laboratory of Applied Geology in the Sorbonne. In 1934, Pierre Fallot, a scientific advisor to the Moroccan government, invited Joubert to assess mineral resources, geology and hydrogeology. In 1946, Georges Joubert drafted the first sort of high-quality geological map of entire Morocco, shown here, and took charge of the Service Géologique du Maroc. And Joubert also developed a lithostratigraphic scheme for the Lower Cambrian in the Anti-Atlas, shown here. It will be topic of part 2 of this presentation series. Well, in 1960, Joubert presented a doctorate thesis in Paris and was appointed coordinator of the Commission for the Geological and Tectonic Map of the World for Europe and Africa. In 1967, Georges Joubert joined his brother Boris at the CNRS in France after they had had a 35-year period of professional separation. Georges Joubert is the author or co-author of over 300 scientific publications and co-author of the first geological atlas of the world, in charge of the geological and tectonic map of Africa. He died in 1986 in Bourg-la-Reine near Paris. Henri Termier was born in 1897 in Lyon, in France. He studied at the University of Montpellier in 1923 to 1925 and entered the Geological Survey of Morocco, where he worked until 1940. He primarily studied stratigraphy and paleontology and presented a thesis on his results in 1936. In 1946, he became a professor at the University of Algiers, and in 1955 received a chair at the Sorbonne University in Paris, where he headed the General Geology Laboratory from 1916 on. In 1945, Henri Termier married the paleontologist Geneviève Delpay, who was a research director at the CNRS and a specialist in gastropods. They subsequently published a series of joint articles and books. The most spectacular of these was a series of 5 volumes on the fossils of Morocco, published between 1947 and 1952, a huge task even at that time. Unfortunately, all fossils in the volumes were only shown as crude line drawings, and the limited space made the description of them lamentably short. Nevertheless, this was a sort of a first compilation of all Cambrian fossils of Morocco. Henri Termier also collected Cambrian fossils in Morocco and published them in a sort of occasional papers. Remarkably, some Cambrian localities are only known from the singular findings of such fossils and never were studied again. Here 2 examples of Lower Cambrian archaeocyath from the High Atlas. Here this is a thin section of a cup of Dictyocyathus gundafensis. And this is a crack-out sample of an archaeocyath described as Orpicyathus ayaciforme, both Termier's originals. The Cambrian stratigraphy received a pronounced momentum when Pierre Huppé entered the stage. Huppé studied sciences at the universities of Strasbourg and Nancy and graduated in 1931. Huppé was well known for his drawing skills, for which he won prizes at the university. He then became a high school teacher of natural sciences. In the 1930s, he performed geological studies in the Pyrenees, mainly on structural geology. Between 1945 and 1949, he worked for the CNRS and in 1951 entered the Laboratory of Geology at the Sorbonne University in Paris. At the same time, Huppé began to publish works on trilobites, which were ranked among the most influential of the 1950s. His work formed the basis for the classification in the treatise on invertebrate paleontology, a sort of Bible for invertebrate paleontologists. Huppé's work on the trilobites of the Lower Cambrian of Morocco started in 1950-1951 and peaked with his monograph in 1953 on the Lower Cambrian trilobites of the Anti-Atlas, the title page of which you see here. Huppé collected fossils during subsequent field trips, but moved into trouble and obviously did not return to field work in Morocco after 1956. He received the Charles Doolittle Walcott Medal in 1957. In 1959, he received his doctorate with a thesis titled Nouvelle contribution à l'étude du Cambrien marocain, which complemented the monograph of 1953 but was never published validly. In 1960, he was appointed professor of paleontology of the Sorbonne, where he founded the Laboratory of Invertebrate Paleontology in 1967, which he directed until his retirement in 1977. Merely as a byproduct of his initial studies, Huppé introduced the first detailed biostratigraphic scheme for the fossiliferous Lower Cambrian or Georgien in the Western Anti-Atlas. All zones are based on trilobite genera or species, and this scheme is also the first ever proposed detailed biostratigraphical subdivision of Lower Cambrian successions. The Cambrian in the eastern part of the Anti-Atlas and its trilobite content was first studied in some detail by Louis Clarion. Clarion was a civil mining engineer who entered the Bureau de Recherche Participation Minière in 1930. In addition to his regular duties for the organization, he undertook important basic studies on the Moroccan geology and particularly the coal basins. In 1935, he studied the Saro, Maider, and Tamlelt regions of the central and eastern Anti-Atlas, where he recognized the Precambrian basement series to be unconformably kept by a seemingly Cambrian volcanosedimentary complex. This so-called Cambrian is now known as the Ediacaran Wasosat supergroup, which was assigned to the Georgien as well in Neltner 1938. However, Clarion also recognized the sedimentary cover on top of the Wasosat supergroup with Cambrian trilobites. The latter formed the major source of Neltner's 1938 thesis. But let's now jump to the eastern High Atlas, a region termed the Tamlelt Inlier, which has the least studied Cambrian rocks of Morocco. The Cambrian rocks in the Tamlelt Inlier are known since the early 1950s, primarily by investigations of Renaud Dudrenet. They are distributed in isolated mountains in the deserted landscapes, primarily in the region of Boucaïs, east of Ain Jair, and north of Bou Anan. There are enormous structural complications with intense folding and partly overturned succession, which makes it difficult to recognize the precise stratigraphy. Relatively recent studies allow to summarize the stratigraphy as shown here. Formation names are adopted and partly modified from a synthesis of Wari in 2003, and it is also included in the new explanations of the Selmo map sheet 1 to 50,000. Age assignments are based on some trilobite occurrences and also biostratigraphically useful brachiopods. This photo shows the entire known Lower Cambrian succession consisting of the Jebel Menhuhu, Al-Hamrat and Nidjel formations. Please note that the succession here is overturned. The Jebel Menhuhu formation was first described under various names and seems to reach a thickness of about 250 meters. The rocks rest unconformably on older, mostly ediacaran volcanic rocks, and they are typically deformed, apparently wavy calcareous beds with thin silicified shale intercalations. What can be identified are plenty of microbial mats, turning locally into stromatolite-type bioconstructions, but other reports of organismal remains have not been confirmed. The structural deformation results in misleading aspects of bioconstructions. Real fossils, however, were collected from the Al-Hamrat formation, a thick unit composed primarily of greenish shales and sandstone intercalations. As a first example, I show here cranidia of an endemic trilobite species of the genus Zeuxienda, which is known as well from the upper part of the Lower Cambrian in the western Anti-Atlas and from Andalusia in southern Spain. These are remains of the trilobite Termerella latifrons, which was one on the list of UP's biostratigraphical index species for the upper part of the Lower Cambrian in the Anti-Atlas. It comes from approximately the same level as the Zeuxienda species. The Nidjel formation is a recessive unit consisting of quartzitic arenites with a thickness of 30 to 70 meters. The overlying Baten-Iljdari formation is widely distributed but mostly poorly exposed and developed as a succession composed primarily of shales and sandstones. There are only wild guesses on the thickness of the unit, which are sometimes thought to reach more than 2,000 meters. Thin, that means 30 to 10 centimeter thick reddish carbonate lenses with fossil sclerites shown in the lower photo were previously assigned to the upper strata of the Nidjel formation, but they have to be regarded as representing transgressive pulses in the lowermost part of the Baten-Iljdari formation, similar to the Bresch-Amikmaka bioclastic limestone beds of the Anti-Atlas. Such calcareous beds occasionally produced nicely preserved trilobites of some biostratigraphic significance, referring to the lower Middle Cambrian boundary interval. They seem to indicate an age corresponding to more or less exactly to the Cambrian stage 4 Wuyuan boundary. Shown here is one species, Kingas bidoides destombesi, which is also known from the eastern Anti-Atlas. This is a famous species, Kingaspis campbelli, which was first described from the Dead Sea shore in Jordan and then identified from several other regions. However, these specimens from the Tamlelt Inlier are the only ones outside Jordan which can be assigned confidently to this species. The Hasid-Wish formation is dominated by poorly stratified, fine-grained or cross-bedded fine to medium-grained sandstone with calcareous sandstone and quartzitic arenites. It may indeed be a stratigraphic equivalent of the El Hank formation of the western Meseta region which we met earlier. An even younger biostratigraphic marker comes from near the Maxim El Arish ridge, near the southern rim of the Tamlelt Inlier, where the Czechoslovakian paleontologist Vladimir Havlicek in 1971 described the Billingselid brachipod Sacogonum saccatum. This genus is also known from the central Anti-Atlas and from the Moroccan Meseta, where it is found in the strata of by B and H. And this completes this first part of the Cambrian of Morocco. I would like to thank all people who contributed to this presentation by providing data or photos, and those who were co-authors on relevant articles over the last decades. I would be happy if you would be interested in part 2 on the Cambrian of the Atlas ranges. Thank you.